Hello. Now, today we are going to be looking at our tangents to our curves, so our dy dx, and we're going to be looking at when functions are increasing and decreasing. To begin with, we're going to do a recap of how it is we get equations or deal with tangents to curves in slightly different contexts. So a reminder that dy dx, our derivative with respect to x, is a rate of change, so how quickly something is changing or how quickly things are changing relative to each other. An example of that would be speed, like distance over time is our speed, so that's a rate of change. And the other one, the one we're going to focus on for today, is that dy dx is a slope of a tangent to a curve. And I have a little sketch drawn in here. If we have our quadratic looking curve here, and we have our dy dx would dy dx or f dash x at our point of contact is going to be the same as the slope of our red line L1, and the slope of L1 is going to be M1. So this is the version we are going to be focusing on today, but it's important we always have the fact that it's rate of change of something in the back of our minds as well. One quick note, which is going to be important in a few minutes. A function is increasing, that is, it's going upward if dy dx is positive. If the slope of the tangent to the curve, if the slope of the curve is positive, that means that the function, the blue line down here, is going upward. We know that when dy dx is 0, we're going to be up at the top of a hill or the bottom of a valley. We've talked about that before. When we're going downhill, when we're dropping, or when our function is decreasing, dy dx is going to be negative, because dy dx being negative means we have a negative slope of the tangent to the curve. So our curve is going downward. It has a negative slope in that region. And then we see as we increase even more, this is a positive cubic type function. As we increase past the minimum, we are getting back into having a positive slope, so a positive dy dx, which means greater than 0 in mathematical language. Now, let's jump into this and recap what we already know about getting equations of tangents when we're dealing with dy dx. So I have y is equal to 3x squared minus 6x. Find the equation of the tangent to the curve at x is equal to 3. I'm asked for the equation of a tangent to the curve. This tells me two things. Tangent to the curve means I'm dealing with dy dx, and I know that without any further prompting. And equation of a tangent tells me that I'm dealing with the equation of a line, so I'm going to open my log tables and I'm going to write down the equation of the line formula. Y minus y1 is equal to m on x minus x1. I see equation of a tangent is a line, I write down the equation of the line formula, and I see what I need in order to get stuff to sub into this formula. Well, x1 is dead simple. It's just 3. I'm told I'm looking for the situation where x is 3. So I have one of those points. I don't have y1, but that's just going to be my function, y or f of x, when x is 3. So I go back to my original function. I'm going to be able to use that to find my y1. And my m is going to be my dy dx. Or as I've used function notation here, I'll just remind you of it. If f of x is my function, then f dash x is going to be my derivative. So I'm looking for the derivative when x is 3, and that's going to give me my slope. So I now have a game plan for what it is I need to do. So let's get my y1 out of the way. So I have y is equal to, or if you prefer, f of x is equal to 3 on 3 squared minus 6 on 3. When I put that into my calculator, I am going to get 27 minus 18 is 9. So my point on my curve then is going to be 3, 9. So that's my x1 and y1 sorted. I have those now. Now I need to find my slope. The next, so we want to find the slope. So let's find m. So m is going to be my dy dx. So I take my original function. Y is equal to 3x squared minus 6x. Always write down what you're going to get the derivative of directly above where you're going to get the derivative. This is already in power notation, so it's very straightforward. Dy dx is equal to multiply by the power and subtract 1 away from the power. And I want to know what dy dx is when x is 3. So I want to know dy dx at x is equal to 3. I just sub in 3, and this is going to give me the slope of my curve, the slope of this curve when x is 3. And 18 minus 6 is 12. So I have all of the information I need now. That is my slope. So I have y minus y1 is equal to m on x minus x1. So I have y minus, I have my point written up here, but I should rewrite it directly next to where I'm going to sub in. Otherwise, the chances of making an error are very high. So I have my m directly written above my formula, and I have my point directly written above my formula. Minus 9 is equal to 12 on x minus 3. And if I had negatives in here, I'd have to put everything in brackets. So y minus 9 is equal to 12x minus 36. I'm going to leave this in y is equal to mx plus c form, because I wasn't given any particular specification for what it had to be rearranged to. If I was told in general form, I'd bring everything over or to one side. So the x, the y, and the number would all be equal to 0. But I haven't asked that in this case, so I'm just going to leave it in y equals mx plus c form. And that is minus 27. Now, very briefly, something that we could do if we were stuck in the question. So we do this up at the top if we were confused, if we needed a little bit of an anchor. This is a very easy function to sketch. So I'm just going to point that out to you. Y is equal to 3x squared minus 6x. If I wanted to, what do I know about this function? I know it crosses the y-axis at 0, because when x is 0, y is 0. I can see that immediately. And I know that I can factorize it very easily. I always look for common factor first. So if I wanted to know the roots of this equation, I could take out a common factor of 3x. I'd be left with x minus 2. And if I'm looking for the roots, I set my y equal to 0. So 3x is equal to 0. X minus 2 is equal to 0. X is equal to 0. X is equal to 2. So this allows me to draw a quick sketch. It's a positive quadratic, and I know that its roots look something like that. I know that I'm crossing the origin for one of my roots, and I know that x is 2 is the other one. So if I draw that in, that's 1, and then 3 is what we're looking for. So we're looking for the equation of the tangent at our x is 3. So we're looking at the equation of that red line there. Being able to draw that sketch gives me an anchor for what I'm going to do, just like writing my equation gives me an anchor for what I'm going to do. Not necessarily what we'll do in the exam, but it trains us to be able to see the questions in the way we're going to need to be able to see them in the exam. Now, let's have a look at our second question. If L1 is equal to this, find the points where the slope of the tangent to the curve of f of x are parallel to L1. Lots of language in here. I have points plural, so I'm expecting to get more than one answer. I have slope of tangent to the curve, so I have dy dx. Slope of tangent to the curve tells me I'm dealing with dy dx, and I have the word parallel, which also makes me think of slope. So I want to know, when is dy dx, when does dy dx have dy dx for this function have the same slope as my line L1? So to do that, I need to know, when is dy dx equal to m1, where m1 is the slope of my line here. So I need to know the slope of L1. So L1 is equal to, is 2x minus y minus 5 is equal to 0. Rearranging that, I'd have y is equal to 2x minus 5. So my slope then, m1, is equal to 2. Y is equal to mx plus c. So m is 2. So I want to know, when is dy dx equal to 2. So I need to get dy dx for my function. Write down the function we're going to get the derivative of. I've written it in function notation this time, so I have multiply by the power, subtract 1 away from the power. Minus 4x to the power 1 minus 10, and derivative of a constant is 0. Simplifying that, I have x squared minus 4x minus 10, and I want to know, when is f dash x equal to 2. So x squared minus 4x minus 10 is equal to 2. I now see I just have a quadratic that I'm solving. So I have minus 2 from both sides. And I'm solving for my values of x. And I see that I am able to break that up into x minus 6 by x plus 2. So I have x minus 6 is equal to 0, and x plus 2 is equal to 0. Rearranging, I get x is equal to 6, and x is equal to minus 2. And then I am subbing, I'm asked for points. That implicitly means coordinates, so I have to find my y values as well. So I sub back into my original equation. Y is equal to x cubed all over 3 minus 2x squared minus 10x plus 1. Subbing in, you get y is equal to 6 cubed all over 3 minus 2 on 6 squared minus 10 on 6 plus 1. Subbing all that in, I get 25. So this point is going to be x is 6, y is 25. We can do the same thing for x is equal to minus 2, sub it into our original function, f of x, and we get 31 all over 3. For doing interpretations of what's going on, it's often a good idea to write that in decimal form, because for most people anyway, it's easier to empathize with a decimal. You know roughly that it's 10 and a bit, which is a lot harder to interpret from 31 all over 3. So these are our 2 points, and that is what we need for our equations of tangent.